Howdy. Howdy. All right, as we start to get going, I again want to emphasize that we really appreciate all of you coming and what a great week it's been for this Veritas Forum. And we do have, again, as Zach mentioned, the Veritas Encore event next Thursday at 4 p.m. in Rudder 301. One point to mention there, some of you young Aggies may not remember, but Walter Bradley is a longtime mechanical engineering professor here and really one of the intellectual godfathers of the university. All right, let's talk about tonight. The format is going to be that Dr. Collins will speak initially and give the initial argument, and then Dr. Velasco will respond, and then we'll have a quick, after those two 15-minute presentations, there'll be a 5-minute response and another 5-minute response, and then we'll have a brief discussion up here, kind of in a panel-type format with me moderating. Please tweet questions in, as Zach mentioned, and we'll be in good shape. And once that wraps up, then we'll move to an open mic Q&A session. Okay, before we get going, some of y'all may have seen we have two speakers, they're on different sides, this is a debate, and when you think of debate, the kinds of things that might come to your mind are like the debates you see on Facebook, or the debates, like political debates, and that's not kind of what we have in mind at all tonight. There's going to be no one's going to make up a silly nickname for anyone else, nothing like that. No one's going to sound slogans. So one thing I can tell you about both of our presenters is they're committed to truth, and the goal of tonight is not to pick a team and say, go team. It's going to be, we have a particular argument, one of the most interesting arguments out there, and we're going to try to evaluate it. That's the position our speakers are coming from, and that's the attitude I'd like you to have as well, as think through this argument. Does it make sense? Is it compelling? How else can I think about it? And my long-term hope is that the discussion would not end here tonight, but that you can go out and have coffee with each other and think, oh, what did you think? And so frequently in the university setting, we talk about things that don't really matter. We talk about sports, that's interesting, but it doesn't really matter. But tonight, the topics are things that really do matter. And so without further ado, I'll go ahead and introduce both of our speakers. Our first speaker is going to be Professor Robin Collins. He is a distinguished professor of philosophy at Messiah College in Pennsylvania. He earned his Ph.D. in philosophy at the University of Notre Dame, and he has graduate-level training in theoretical physics from a university in Austin that I will not name. He is... Do your thing. Okay, go ahead. He has written over 50 substantial articles and book chapters in philosophy with some of the leading academic presses spanning the areas of philosophy of physics, philosophy of science, philosophy of religion, and philosophy of mind. He's given invited talks at many colleges and universities, such as Oxford, Cambridge, Stanford, and Yale, and has appeared on several nationally broadcast programs, such as the PBS show Closer to Truth and Stanford University's Philosophy Talk Radio. He is internationally recognized as a leading expert on the fine-tuning of the universe for life and its philosophical implications. His recent work explores the ways in which the laws and fundamental parameters of the universe appear to be optimized for our ability to do science and discover the universe. And he recently received a very large grant from the John Templeton Foundation for finishing work in this exact area. Our second speaker is Dr. Joel Velasco. He's an associate professor of philosophy at Texas Tech University. He specializes in the philosophy of biology as well as more general philosophy of science and epistemology. In particular, he's worked on issues including biological taxonomy, phylogenetic inference, the use of probability in scientific reasoning, and the structure of evolutionary theory. His work has appeared in a number of places, such as Philosophy of Science, the British Journal for the Philosophy of Science, Biology and Philosophy, and Systematic Biology. Okay, so those are our two speakers, and y'all got the format. Dr. Collins will speak, Dr. Velasco, short responses both ways, and then we'll have more of a panel format, and then you can ask your questions. And I'll go ahead and get on your case ahead of time. We are in the question mode, we're not in the comment mode for this evening, and then after some of that question and answer period, I'll dismiss us so that we don't go too long into the night. Okay. Now, would you join me in giving a big Texas A&M welcome to Professor Robin Collins? Thanks.
Okay, it's good to be here. I must begin by apologizing. I forgot to bring my boxing gloves. The other thing, I hope after I'm done here, I'm leaving tomorrow for LA, I want to find who the 12th man is. Yeah. So, today I'm going to speak on just present the basics of the fine-tuning argument for the existence of God. It's considered one of the, by many people, including myself, one of the strongest arguments for the existence of God. It's going to be a very short, because usually I take about 50 minutes to do this, so it's been a very shortened presentation. So I'm going to get started right away and get my timer on, so I do about 15 minutes. Okay, so cosmic fine-tuning refers to the fact that the fundamental structure of the universe has to be set in very precise ways in order for life to exist. If you want to think of an analogy, it's like the universe is like a biosphere. You know, biosphere is one of those things you put in other planets to support life, and everything has to be adjusted just right in order to sustain life. And the kind of life in particular is what I call embodied conscious agents. So in what ways is it fine-tuned? Well, there's three basic categories. It has to have the right laws of nature. A law of nature is just something that tells how nature is supposed to operate. Like there's a law of gravity that if I drop this, it will fall. Masses attract each other. So, and then it has to have the right values of the fundamental constants. These are numbers that go into the fundamental laws of nature that are required to sort of specify like how strong gravity is supposed to be. And if you've taken a physics course or elementary science, it's that G, force equals G times mass, two masses divided by the distance squared between them. And then there's the initial distribution of mass energy in the universe. So I will give examples of all three of those. So let's just start with the easy one of the laws of nature, just the basic law of gravity that says masses attract each other. What if you just kind of deleted that law from the program for the universe? Well, what you would have is masses, the matter in the universe would never clump together, which would mean there wouldn't be any planets and there wouldn't be a place for beings like us to evolve, and there wouldn't be any stars, which are necessary energy sources to allow for life like us to exist. Another example is concerning the atom, one of the basic building blocks of life. So we all learn hopefully in elementary school or high school, that the atom is composed of electrons orbiting a nucleus, and the nucleus is composed of protons and neutrons. And hopefully we've all learned that like charges repel each other, so the nucleus, the protons, should repel each other in the nucleus, right? So when they initially hypothesized the atom, they had this difficulty. How could the nucleus stay together? So what they had to hypothesize is a special force called the strong nuclear force to hold the protons together. And here we go. I should say this is a picture of me when I was running for the governor of California, but another guy beat me. That's how things go, so I went into philosophy instead. So this force has to hold the protons and neutrons together. It has to be of just the right form. Like gravity is not of the right form. It reaches over a long distance from like the sun to the earth. This has to be, just as shown in the picture, has to be short range. Basically, it has very short arms, can keep the protons together, but can't reach too far. It's much stronger than the electromagnetic force. If it reached further, it would grab all the other nuclei together and pull them all together. You would get one big black hole, and it'd be the end of life. So it has to be a force there and of just the right form. That's an example of having to have a special law. There's about 14 cases of these you can count of special mathematical forms of laws to have life. I've given you two of them. The next one is the fundamental numbers I'd mentioned that go into physics. And an example of this, I'm going to give one example just because of time considerations, this is the one that's the most talked about in the physics literature. It's called the cosmological constant. According to the Big Bang theory, the standard theory of how the cosmos, the universe began in a Big Bang and is expanding. So space is expanding. But there's this term in Einstein's equation that if it's positive, it causes the expansion to accelerate, and if negative, causes it to rapidly deaccelerate. It has to be just within a really fine margin around zero in order for the universe not to expand too rapidly so that stars and galaxies and stars can form. Otherwise, if it expands too rapidly, the masses can't clump together. And if it's too much less than 0, everything will collapse back in on itself before galaxies and stars can form. So how fine-tuned is that? Well, in the literature, it's a whopping 1 part in 10 to the 120th power. That's scientific notation. 10 to the 120th power means 1 followed by 120 zeros. That's like a billion, 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 and say that for a while. So it's an extreme, unimaginable level of fine-tuning. So, and there's quite a few of these fundamental parameters have to be fine-tuned to that degree. So that one determines the rate of acceleration of the expansion of the universe, or deacceleration. This is the next one is the initial distribution of mass energy. This is the most impressive of them all. So here is, on the diagram, you will see a diagram of the Big Bang. And if you look along that diagram, you'll see here's the Big Bang starts there. Sorry. Big Bang starts there, and then eventually stars and galaxies form, and then eventually human beings out here. And when you look here, you might just think that's just a kind of homogeneous distribution of mass energy. It doesn't have to be anything special about it. Just like if you looked at a protoplasm here, zygote, it just looked like nothing special unless you look down to the deep structure. Then you would see it'd have to be structured just right in order to form a human body. Likewise, for the distribution of mass energy at the Big Bang had to be in a very, very precise structure in order for galaxies and stars to form and eventually human beings to exist out here and think about that whole thing. So how precise must this be? So you can ask for this. Roger Penrose, he's one of Britain's leading theoretical physicists in cosmology. And there's a fairly simple calculation you can do for this. And he says, in order to produce a universe resembling the one in which we live that can have life, the creator, and he's using the creator as a kind of a device to explain this. I don't know if he believes in God or not. The creator would have had to aim for an absurdly teeny volume of phase space. What is phase space? It's a physicist's way of measuring the space of possibilities. So the phase space of a single coin that you flip is heads and tails. The phase space of 2 coins being flipped is heads, heads, tails, heads, heads, tails, and tails, tails. Okay? So he's saying how much of the space of possibilities? It's a whopping 1 part in 10 to the 10 to the 123rd power. And I mean, it's hard to even get imaginative your hand around that, but let me just give you an imaginative device for that to think about it. It's if you had sheets of paper you were duplicating on a Xerox machine and you had zeros, and the first one you put a 1, and the rest had zeros, and you duplicated so many they filled the entire universe. That number that you would have would be not nearly as large as this number on the screen. That's the 10 to the 10 to the 123rd power. So it's an enormous degree of fine-tuning. Now, this need for fine-tuning is widely recognized, as you can see from this quotation by the famous cosmologist, the late cosmologist Stephen Hawking. The remarkable fact is that the values of these numbers, the constants of physics, seem to have been finely adjusted to make possible the development of life. And as I pointed out, even if one case is not as secure, there's a cumulative case, many different lines of evidence point to the same thing. There must be an enormously precise structure in order for life to exist. Now, what's the main responses to this? One response is just to say this is just a brute fact. You could say it just happened by chance, meaning there's no further explanation. Another response is, and I'll explain what that is in a moment, the multiverse response. Then the third major response is to say the universe is an act of divine creation. I'm going to look at each of those responses in turn. So, especially among physicists and cosmologists who think about it, hardly any of them accept the brute fact hypothesis. Why? Well, let's suppose you found, and if you're a college student, maybe you find instead of ink spill, a mold growing in this form in the back of your roommate's refrigerator. You would not say it just happened by accident. Why? Because it's highly improbable and meaningful. You would say, well, your roommate designed it that way. You wouldn't subscribe something like that to an accident. But if you wouldn't that, and that's not nearly as improbable as this initial configuration of mass energy. It's vastly more fine-tuned than that would have to be to get that picture of Abraham Lincoln. So it seems like that is not plausible at all. It's very improbable, and there's something very meaningful about it. So that causes people to go to the multiverse hypothesis. This is the most, among non-theistic cosmologists, this is by far the most widely advocated hypothesis. And this says there are something enormous number of universes, each one with different values for those basic numbers, those constants of physics, like the cosmological constant, each one with different initial conditions. And if you get enough of those, just like if you produce enough lottery tickets, you're going to get a winning number. Eventually, if you produce enough universes, you're going to get one that has the right structure for life. That's the idea. So we are winners then of the cosmic lottery is the idea. Now, the most popular version of this universe generator hypothesis, or this hypothesis, is that there's some physical process that generates these universes. And here's my cartoon image of that, a little thing putting out smoke and going on a conveyor belt with universes. And every universe that's being generated has a different set of values for the constants of physics and the initial conditions. So what is wrong with that hypothesis? Well, I'm going to only offer one critique right now. And the critique will be that whole generator itself would need some kind of fine-tuning. I used to own a bread machine. It's now defunct, and I don't see them around. People don't use them much anymore, but in the 90s they were popular. And unless it was correct, the program was correct and was correctly operated, like you put in the right ingredients, which sometimes I would forget, leave out the yeast, I would get a hockey puck. Wouldn't get a good loaf of bread. So everything has to be just right to produce a decent loaf of bread. And that's only producing loaves of bread. How much more with a universe generator? So it has to be well built in order to generate even one single life-supporting universe. And just a plug for the brand name, well built, it's an actual brand name. You know because of the name, it's good stuff. That's all I'll say. Move on. So what are some other problems, and I'll have to get to them, by time and response if this issue comes up. There's other major problems with the multiverse hypothesis. Boltzmann brain problem, completely speculative, takes as much faith to believe in this as God, does not explain other features of the laws, their beauty, nor the fine-tuning for scientific discovery, an area I've been actively working on. So to summarize everything here, we have three major explanations. The brute fact, that seems, in many people's mind, utterly unbelievable, given the level of fine-tuning. There's the multiverse, and then that seems to push the fine-tuning up one level, and then there's God. And now I will leave it to, my time's up, and I will leave it to Joel Velasco to respond to me.
All right, thanks. It's amazing how many people are here, and I'm really glad that you're here. And I want to say that when I heard Dr. Green say what the Veritas Forum is about, that is, it's a search for truth, and both of us are interested in that, I completely agree. That's exactly why I'm here. And so why I'm here, I think, is to help us all understand this argument better, sort of think about it more, and so I'm going to try to present a bunch of reasons that I think should make you think a little bit harder about this. Now, I myself don't find the argument that convincing, and so I'm going to try to say why, and why I think you shouldn't either. So first of all, let me just say, I think there's kind of two major reasons that I personally don't find it that convincing, although they're not really about the argument in general. And so it's going to be, but I want to mention them. First, I think the history of science dictates that sort of over and over again, we think we're special, and it turns out that we're not, right? So we used to think that we're the center of the universe. We used to think that human life is special as opposed to other sort of living things. I actually just found out last week that William Herschel had a really good argument that we are at the center of the Milky Way galaxy. Turns out we're not. There's cosmic dust in the way, and that dispersed the light in just the wrong way. And sort of over and over again, the history of science makes us realize that, in fact, we're not special. And the fine-tuning argument is just one more argument that makes us think we are special. And so just inductive logic tells me there might be something wrong with it. And now, more controversially, I think also, over and over again, we think that there's things that could only be explained by God, and it turns out that there's some other explanation. But now, neither of those are about the argument in the specifics of the argument, and so I want to talk about that. This will be my first, in some sense, first slide and also last slide. I'm going to come back. Here's my summary of the whole argument. Is the universe fine-tuned? It does really look that way, and I think in the end, probably it is. But actually, I think it's not that clear. We need to be careful. Second, does this fact even need explanation? That's also, I think, not that clear. It turns out that, if you think about it, from our point of view, basically no matter what we find, it's going to look amazing and coincidental and special. Could this be a selection effect? And I want to describe the multiverse hypothesis that way. This is... Robin is right. This is sort of the main response from cosmologists today, and so I'll take some time to try to explain different versions of that. And finally, at the end, I'm going to say that even if none of that really works out, it doesn't really seem to me that God sort of helps, that that's not really a good explanation. Okay, so now I'm going to go in detail through these points. First, is it actually fine-tuned? If you try to very carefully formulate the argument, first of all, what you should do is read some papers by Robin Collins. As far as I can tell, he's the best writer in the world about this, trying to be very careful in formulating the argument. And it's extremely difficult, right? First of all, here's something that most people pass over. You need to know what the actual laws of nature are right now. Before you ask if they're fine-tuned, you have to understand what they actually are. And I would claim, for the most part, we don't really know. Worse, of course, it just gets worse, you need to know what the situation would be like if the laws were different. And if you think about that, I think you'll see we don't know, right? So take something like the strong force. So Robin said, look, the strong force holds atoms together. It's true. In the universe we live in right now, as everything is, the strong force is responsible for example, binding protons with neutrons. Now, you can ask yourself what it would be like if there was no strong force, but you don't really understand that question, right? First of all, the strong force is actually united with the other forces, with the weak force and electromagnetic force. You can't just pull one of them out and say, imagine it didn't exist, right? It can't just have a different value. And everything we understand about physics is with the backdrop of knowing how our universe actually works. If our universe worked a lot differently, we have no idea what would happen. Worse, you need to first understand all the possibilities, which I claim you don't really know, and then second, you need to say, okay, so which ones are actually probable and how improbable is it with these particular responses? And I think there's really no way to assign probabilities here. The way we assign probabilities in science is by using the laws of nature and by understanding how the universe works. The universe, the laws, can't give us probabilities about what the laws are. That doesn't really make sense. Okay, now I do want to say, I think after all of that, there's still something very powerful, and that's why I'm here. I'm here because this argument is really interesting. It's not at all a silly argument. It's a very strong argument, I think. And at the end of the day, it really does look like there's something to explain. Almost all serious cosmologists who understand this take this argument very seriously, and you should too, right? Okay, But we just need to keep in mind there's so much we don't know. Okay, now here's what Robin said were sort of the three possible explanations, and I want to sort of break up the space a little bit differently, so I'm going to talk about them. First is what he called the brute fact explanation. Now, really, this captures a couple of different possibilities that we need to think about. First of all, various features of the universe might turn out to actually be necessary, right? So it might look right now like the gravitational constant could be different, and we have no reason for thinking what. But for all we know, it could follow for some deeper law. And just to give you an example, nobody talks about this amazing coincidence that the positive charge of a proton is exactly the absolute value of the negative charge of the electron. Now, we do all these measurements, and we're sure they're almost exactly the same. It just so turns out that atoms are neutral with respect to their electrical charge. And we know, if you think about it, if they were different, everything would be a disaster. But of course they're going to be the same. No one talks about this because there's bound to be some deep explanation for why protons and electrons have just exactly the same charge, only of opposite values. There's bound to be some sort of deep symmetry there. We don't know what it is, by the way, but no one's wondering why these numbers are the same. And there's very plausibly lots of other constants of nature like this. Why is the ratio of this one to this one so special? Well, plausibly they're connected in some way that we just don't understand yet. Okay, the second kind of explanation is chance, which is a very different one. The idea that things could have been different and we were just lucky. And I just want to make a plug to say it's not quite as crazy as you might think. It's not just like the Abraham Lincoln thing. There's a sense in which we have to be lucky no matter what, right? Think of all the things in the universe that had to happen for you to be here, right? If my dad had coughed at just the wrong time, a different sperm and egg would have mixed and I never would have been born. In fact, for my parents to even meet, all of these weird random things had to happen. In fact, my great-grandfather had to come from the Philippines and come to just the right village in Minnesota to see, and actually, all of humans are just lucky, right? If the wrong ape had died in an earthquake 6 million years ago, there would be no humans. In fact, there would be no mammals today, probably, if the dinosaurs hadn't gone extinct in this asteroid. Everything that's happened in the history of the universe has led to us, and retrospectively looks lucky for us, right? And if things were different, we wouldn't be here. That's true. But you don't have to explain every single thing as leading to you, right? You were just lucky. Okay. Now, it's true, it strains credulity to think you're lucky in every single respect. And so I do want to talk about these other hypotheses that are serious scientific hypotheses. So Robin talked about this in terms of the multiverse. I think the better way to think about this is to think about the idea that sometimes when you want to explain something, there's a selection effect. You can explain why you see it, right? So, for example, here's type 1 of a selection effect. I'm not claiming that this is the fine-tuning case, but type 1 is the universe wasn't designed for us, we were designed for it. And I'll sort of give you an example of this. This is sometimes called puddle thinking by, for example, Richard Dawkins and other people after his friend Douglas Adams, who says this in this posthumous collection of his papers. He says it's rather like if you imagine a puddle waking up one morning and thinking, this is this amazing world I find myself in. This hole is just perfectly fit for me. It's staggering, right? It fits me staggeringly well. It must have been made to have me in it. And I'm not claiming that, puddles are as complex as humans or that we fit the world in the same way. But Adams finishes this quote by saying, this is something we need to watch out for, right? There's this thought that when things fit us so perfectly that we're so special, we need to watch out for this. It might be that there's, in fact, another explanation the other way. And let me give you an example of that, one where I think it is the right explanation, is a selection effect. So the Earth is really special. It's really special in a lot of ways, just to lead to life. For example, there's lots of water around for molecules to react in. And by the way, it has to be liquid water. So, for example, the Earth can't be too close to the sun or too far away from the sun. We have this strong magnetic field which protects us from various storms and solar radiation. In fact, Jupiter shields us from asteroids. If Jupiter wasn't there, we would have been bombarded by asteroids just like the moon. There's no way that living things would be on Earth. The moon actually is essential. It actually helps stabilize our tilt, which leads to the seasons and keeps them not from going crazy. All of life on Earth depends on all of these weird features of the Earth. In fact, there's so many more, right? The plate tectonics have to be exactly the way they are. So the Earth is really special, okay? And it's true, the Earth is really special for us. It's not at all surprising that the Earth is special for us. We evolved here, right? We fit the Earth, okay? Now, it's true, at the end of the day, you might think, still there's something kind of puzzling about why there's a planet just like the Earth that's so special. But actually, it's not puzzling at all. There's a lot of planets. There's more than 100 billion planets just in our own galaxy, right? We used to think the Earth was special. Now we're discovering there's way more planets just like the Earth than we thought. Now, we haven't actually found one yet with life, but if you ask a cosmologist, they just assume we're going to, because there's so many planets out there, right? It's not at all surprising. Now, here comes the explanation. So why are we on one with this special features? Well, because we got to be somewhere. We got to be on a planet that has these kinds of features. If there's 100 billion planets out there, the only ones with life are like the Earth. So that's why we're here, right? It's just a kind of obvious selection effect. We couldn't have discovered anything else. Now, the thought is that this is an example of a selection effect, right? The property we're observing, namely that the planet is conducive to life, is correlated with our own observations. The thought is maybe the whole universe is like this too. And so that's where the multiverse comes in. So I'm just going to take 2 minutes to point out, first of all, there's lots of different types of multiverses. Probably the most common one is, if you've heard of it, you probably have heard of the quantum mechanics and the Everett interpretation. But it turns out that that one doesn't really help. Because it's true, everything that can happen does happen, but can happen there means has the same underlying laws, the same constants, so it doesn't really help. But there's other versions of the multiverse, for example, cosmic inflation. So Robin had a picture of the Big Bang, and every picture of the Big Bang you find will look exactly the same. At the beginning, right near the bang, right after that, there's going to be a massive explosion in the size of space. Because that's the going theory, is that, within the first 10 to the minus 36 seconds, there was this huge inflation of space, okay? And it's a natural extension of the Big Bang problem. It solves several problems, including some of the fine-tuning problems, like why the universe is so flat and why it looks the same in every direction. And a natural version solves the special initial conditions problem because somewhere out there in space, there's basically every possible initial condition is tried out somewhere. So the universe is much, 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 much bigger than you think, much bigger than we can see, and somewhere out there is basically every initial condition you can imagine. And so as long as we're somewhere, we're here, right? Now, to be a little bit more speculative, there's some speculative extensions that include that it, for example, just eternally inflates and keeps spawning off universes. That's the universe generator that Robin was talking about. Here's this nice picture from a Scientific American article, I think. And the idea is that as long as the constants of nature can vary each time you get this spawn off, which we think they probably can, at least that's what the model says, you don't need any special setup for the machine. The machine just literally covers every single possibility eventually because it goes on forever, right? It's also worth saying if you watch, say, a Brian Greene TED Talk or something, you'll hear about string theory. So string theory predicts that ultimately all the laws of nature and the constants of nature come out of different dimensions folding in weird ways, and there's a way more ways they can fold that you can imagine, even bigger than the number that, well, not bigger than the Penrose number, but bigger than the cosmological constant number. And the idea is that one natural model is just all of these different possibilities exist somewhere. Space is really, really, really big. And in fact, you can connect it to inflation. That is, inflation is generating universes. It's eventually going to cover every single one of these possibilities, including the ones that have life like ours. So somewhere there's living things. Now you're living. What kind of universe are you in? Well, obviously you're in one that's conducive to life, not one that doesn't have any atoms, for example. So that's what a selection effect is. And there's more. And just to sort of finish up, I need to point out that each of these theories is speculative. It's true. but they arose out of work independently of trying to solve the fine-tuning problem. These are physicists trying to solve other problems that came up with theories that turn out to have implications for fine-tuning. Now, we don't know what version, if any, will turn out to be right. So we haven't solved the fine-tuning problem yet. But I would claim they're all better hypotheses than God. And just to say quickly what I mean is, here's these questions. Would God make a universe with so little life, relative to all the empty space? Would he make a universe where the constants were fine-tuned, or maybe one that was bound to lead to life? Would he make a universe where life depended on physical properties at all? If you think God is a mind with no body, why couldn't he make you a mind with no body? I don't know the answers to these questions, but what I think is that nobody does. And so then they can't really seriously say that God is a better explanation than these other kinds of things. So theism as a scientific hypothesis is not really well defined. You can't really test it. So facts about the physical world can't really be evidence for it. And so just to remind you, there's my final slide. Is the universe fine-tuned? It does look this way, although, we got to be careful. Does it need explanation? Maybe not, although I feel the pull of it, just like you probably. Could this be a selection effect? That's the going theory by professional physicists. But even if that doesn't work, I want to say God doesn't really help. We still would have the same basic puzzles. Thank you.
So, Dr. Velasco, he raised a lot of questions or issues that need to be addressed if you're actually going to fully develop the fine-tuning argument. I think most of these in my work I actually have addressed, so I think they have plausible answers to them, but it's a good point to make. Any of these kind of arguments, this is a really big issue, and so there's going to be a lot of, it's not going to just be a slam dunk right away. There's going to be a lot of questions that arise. So I have a very limited amount of time for response, and I think I'm going to work backwards a little bit on the response. So the idea of the multiverse hypothesis, inflationary multiverses, first of all, I don't think they were actually developed independently of the fine-tuning problem. It was one of the big motivations for inflationary cosmology, was called the horizon problem. Why are things, the universe, so uniform throughout? And that's really a fine-tuning problem. So a lot of it is developed to solve a fine-tuning problem. And the other thing, there is other reasons to reject a multiverse than just simply let's put it this way, the inflationary one is itself, to make clear, a universe generator. It has to have, if you look at the inflationary scenario, and I wrote an article on this that was in a Cambridge University press book with most articles in there by physicists, and they looked this over. And if you actually look in detail at the inflationary scenario, it has to have just the right laws and mechanisms to even produce a single universe. So it does, to some extent at least, push the problem back. It also, these scenarios run into what's called the Boltzmann brain problem, which is a real serious problem. And the problem is this: if you have like a random fluctuation that gives rise to observers, so it's all a result of just a random fluctuation, why we have a universe like we are now in these scenarios. Well, a random fluctuation is vastly more likely to give rise to an isolated observer than an interconnected set of observers. And one way of understanding this objection, it goes back to, it's called the Boltzmann brain, because Boltzmann, in turn of the around 1900, raised this possibility to explain our existence. It was like over 100 years ago. And immediately people raised this objection. And the basic idea can be understood by thinking of monkeys typing on a typewriter. If we have monkeys typing on a typewriter and you think of like a single word and ordered, or even a single sentence, like an observer, like a brain like ours, it's vastly more likely to get a single sentence that's ordered than the entire book that's being typed out ordered by just randomly typing. Well, the universe is not, and so it's vastly more likely that have a single brain that has the order for consciousness and can observe than it is to have all these people interconnected with each other. So the actual multiverse hypothesis ends up making the wrong prediction. It predicts that we should expect ourselves to simply be, by on a selection effect, to be a Boltzmann brain, and we clearly aren't. So I say that on that issue. There was another issue brought up about a symmetry principle explaining some of this. Well, some things can be explained by symmetry principles, and so you have to be careful of what you cite as fine-tuning. Let me give you an example of a claim that I never cited as fine-tuning, but is often cited as fine-tuning, is that the universe has just the right amount of matter in it to balance the expansion rate, so that, and if it didn't, then it's very unlikely we would have existed. Well, if that balance is equivalent to the curvature of space being flat, that zero curvature, well, anytime you get zero, that's a sign of you could easily explain it by a symmetry principle, because you have one thing equal here, like the mass, like Dr. Velasco mentioned, the charge of the proton, you have the charge of the electron, you have a symmetry between them, add them together, they go to zero. Or whenever you have a quantity 1, then a symmetry principle says this thing has to be the same as that. You put the ratio, it's going to be 1. The problem is a lot of other parameters, such as, I mentioned the strength of gravity or the mass of the proton, aren't 1. They're some arbitrary number, and they have to be that arbitrary number or within a small range in order for life to exist. If you you're not going to be able to get any simple symmetry principle to this. Now, you could jerry-rig a symmetry principle to do it, but then you just push the fine-tuning back to saying there has to be just the right symmetry principle or just the right grand unified theory to give you just the right values for these parameters for life to exist. You've just pushed the fine-tuning back one level. You have not solved it.
Okay. So I agree with a lot of what you say. I think you're right to be very suspicious that a symmetry principle could solve all of these kinds of things. And what I was hoping to impress upon you guys is that there's a lot of different steps in the argument. And some things might be explained some ways, other things might be explained other ways. Some versions of multiverse theories might explain some of the constants or some of the other things, and some might not. And in the end, where I think we're at is that we don't know the answer. We don't really know what needs to be explained, what kinds of explanations might work, what else is going on. But one thing that I do think is that these are scientific questions, and they're going to have a certain kind of answer if you're asking a certain kind of question. So if you want to understand why the cosmological constant is the way it is, the right answer is going to involve something about the early nature of the universe or the way the laws are or some other deep kind of principle. It's not an appropriate answer, even if it's true. It's not an appropriate answer from where we are to say something like, oh, it's because this other being wanted it to be like that. That's not really an answer. Science is still going to have to look. And so when I was bringing up, say, the inflation thing, Dr. Collins is right. One of the original reasons people posited inflation, right, the horizon problem, also the flatness problem, those are both fine-tuning ones. The monopole problem I don't think is. I think that's just we don't see any magnetic monopoles. It looks like there should be some. If there's inflation, that can sort of explain why there's not. But inflation is posited as a scientific hypothesis about why the universe looks the way that it does. There's mechanisms involved. It's true that there's a lot of speculation going on, and people add even more speculation by adding sort of eternal inflation and other worries like that. But these are solved in scientific ways with scientific hypotheses and other kinds of tests. So, the BICEP program is looking for experimental verification of inflation right now. Unfortunately, they claimed they had some a few years ago, and it turns out that they didn't. But this is the kind of thing that you can test. Same kind of thing with string theory. It's a serious scientific theory. It's hard to test, but at least they think it's possible. It's the kind of thing you can examine experimentally, right? So are various versions of quantum mechanics. The theistic hypothesis is not the kind of thing that a physicist could examine experimentally and try to figure out if that's the true explanation for why the cosmological constant is what it is. So it's not really on the table in the same way. And that's not to say that it's a silly hypothesis or that it can't be true or that there's clearly no God, so why are we talking about it? It's to say that it's not a solution to this particular problem. And that's sort of what I wanted to say.
All right, folks, it is 8 o'clock on the dot. So what we're going to do is we're going to have maybe 10-ish minutes of kind of discussion here at the table along questions from Twitter. And then after that, we'll go ahead and open up the mic and have more of an open mic effect, and then we'll see how long we go. I will aim to shut it down at a certain point. So I'll go ahead and get us started. All right, that one's good. Okay, great. Can everyone hear me? Good. Dr. Collins, let's start with you. Dr. Velasco alluded to this, but one kind of visceral response that a lot of people have to hearing about fine-tuning is that the universe seems to be fine-tuned to be mostly pretty dangerous, pretty empty and devoid of life, and even a universe that's fine-tuned and allows for suffering and all these kinds of problems. And we think, well, if I were God, I wouldn't fine-tune it this way. How would you respond to that? Is God fine-tuning and optimizing under constraints?
Okay, well, there you go. So one part of that question is it looks really inefficient. Is that what you're getting at? There's a lot of empty space and things like that. And you're a chemical engineer, I take it. And given you're an engineer, you try to do things the most efficient way. But what if you were a chemical engineer with unlimited resources? You wouldn't necessarily need to do it the most efficient way. You might have other goals in mind. You might want to create a universe that exemplified, if your intelligence or your other properties of being if you were an artist. So God is eternal. God is infinite. And so you might want to create a universe that expresses the infinity of God in a finite way. So it's vast. And the eternality of God, very old. So the big point here is when we think of what God would do, we have to be very careful not just do a simple extrapolation of us, what we would do, because God has infinite resources. Now, there's a whole issue of the problem of evil. Why would God create a world with evil? Now, that's a whole huge issue. And I could go into that a little more, but I think I will pass on it just right now.
Great, thanks. For Dr. Velasco, one question I want to get into is what you mentioned at the very end, which seems to be the idea of science's a priori commitment to methodological naturalism. You said the theistic explanation is not the kind of thing that a physicist can appeal to. And so if we accept that and we say, okay, when I wear my scientist hat, I only throw out naturalist explanations because that's the rules of science. But just for what we believe in our everyday lives, can we take that hat off and open ourselves up to the theistic explanation?
Certainly, I think in your ordinary lives. Also, I think in your scientific lives. Actually, I don't think scientists should be committed to methodological naturalism in a strong way. We have to be really careful about what we mean. If the supernatural just means God or something like that, it would be okay if you had a particular story about, for example, I think God did it this way, using this mechanism and this kind of thing, or I believe in this exact kind of God. But there's this tension. So what I said in my presentation is problematic, for sure, but I do think there's a tension. The more you specify the kind of God you have in mind, and the more you say, oh, I think he did this and did it this way and did it this way, then it's going to look like you haven't really solved the problem. For example, it's the universe generator problem, the kind of thing that Robin was talking about. If you have a version of design where you say, I think the universe was designed, but I don't know exactly what God is like, I just think there's something there, then that's when you can't really say, here's the probabilities, here's how God would do it. So there's this tension. If you can turn it into a kind of testable scientific hypothesis, and then I think it's not really going to solve the fine-tuning problem. Or you can leave it as this completely undefined, open, God did it, and then it's not really a serious scientific hypothesis. Certainly in your own life, you can believe these things if you want to, but I think you should believe things that you have evidence for. And I think it's hard to see how you could have evidence for something that's sort of kind of so undefined without really, doesn't sort of make predictions in a relevant way. I think I should sort of stop talking, but
Can I respond a little bit
Yeah,
to that? So there's a couple pieces of the response I would give. First of all, I think you have to be aware of when it's appropriate to have scientific explanations, when to demand them, and when to not. So you can think of a kind of clock analogy. Let's suppose we were beings in a clock, and we would try to figure out what the gears, these are old style clocks, not the ones today, how the gears and springs work as explanations for why the clock handles move the way they do. That would be science to the little clock beings. But it would be not their science, could not explain why there was a clock to begin with, why it had this little button when you move it, the sound goes off. Then you would have to appeal to purpose. So you have different levels of explanation. When you get to the ultimate laws of nature, the ultimate structure and initial conditions, there's when it becomes more and more appropriate to appeal to something outside, because science has to start with a set of laws and a set of initial conditions to do its explanation at all, just like you have to start with the clock. So that's one piece of it. So the second piece is looking at what you're requiring to be explained. One kind of explanation, what it tries to do, is give you the underlying mechanism. So you can write in the textbook, this is how the process by which this came into being. You're not going to get that kind of explanation by appealing to God. We can't go into the processes by which the mind of God works. So it's not going to be like a scientific hypothesis. Now, I don't think theism is a scientific hypothesis. I think it's a metaphysical hypothesis, though there can be scientific evidence for it. But another thing you want to do explanations for that apply to this sort of case, like in the case when you appeal to purpose. So purpose is perfectly legitimate, like when I talk about that somebody wanted to produce the picture of Abraham Lincoln. I'm not appealing to a scientific explanation. I'm appealing to a scientific explanation based on purpose. And we do that kind of explanation all the time and we find it legitimate. I'm not telling you how it came about. I'm saying, giving an explanation. And why do I want that explanation? Because what I'm looking for is something that takes away the enormous coincidence of there being that mold in the pattern of Abraham Lincoln in the back of my refrigerator. And so I say it must be the result of an intentional agent. That's how to think of what is going on in the case of this sort of argument.
Several of the questions that have come in from Twitter relate to the multiverse and whether we should expect more evidence for it in the future, or is it the kind of thing that you just can't really get evidence for, and so we just have to consider it an alternative hypothesis? What do you think, Dr. Velasco?
Well, this is going to depend on exactly the type of multiverse you mean and what you mean by it. So this gives me a chance to talk about the first kind of multiverse that I didn't really speak about, which is the Everett-style interpretation of quantum mechanics. So there, we have tons of evidence, and we can keep getting more evidence, or we could get conflicting evidence for the equations of quantum mechanics as they are. So for example, the Schrodinger equation. What's special about the many worlds hypothesis, as opposed to other interpretations, is that they're sort of explanations of the underlying reality of what explains why those equations hold. So we are testing those equations. We have lots of evidence for quantum mechanics. We can get more, we can get less. But whether the right way to think about what's going on is that there's multiple parallel branches of reality, or whether there's just one and it decoheres, I'm not sure that you could get empirical evidence for that. Now, a different kind of multiverse, for example, inflation, we can get direct evidence for inflation or against inflation. That's an empirical hypothesis about the early nature of the universe. And depending on what we find, we could find out that inflation maybe just happened one time, and so there's not a multiverse. We could find out that it would continue to spawn, but that the constants would be fixed each time, and then it would be a multiverse that wouldn't help us. Or we could find out that the constants could vary each time. So that really is an empirical hypothesis. And that's why people have gigantic, large grants trying to find gravity waves in the early universe, is because they think it is the kind of thing that you can discover. Whether it's going to turn out true or not, people like Roger Penrose think it's going to turn out not true. Many other cosmologists think it's going to turn out true, but everyone thinks it's going to turn out that we're going to find out one way or the other.
I have a big, messy question for Dr. Collins.
Can I just say one thing?
Go ahead.
I agree. Some people say the multiverse is not testable, these versions. I agree it is testable because although you never can observe these other universes, you could get evidence for a particular process that the process with very high probability would lead to other universes. And so it is actually indirectly testable. So I would agree with that.
So I have more of a theological question. If God fine-tuned the universe, does he want to be known? Does he want this fine-tuning argument to be clear so that his existence is clear? Like, is there a hiddenness problem? Like, what do you think about God's desire to be known based on arguments like this?
Well, I think, okay, this gets into the whole hiddenness issue, the hiddenness of God, and how you'd respond to that hiddenness issue. On the one hand, you don't want God to be too evident. For one thing, if God's too evident, it will take away our free will. I'm driving down the freeway. The speed limit is 55 miles an hour. I don't have the free choice to decide not to break the speed limit if a cop car is in my rear view mirror, not to decide to break the speed limit for its own sake, to obey the law, because I see the cop car there. It's going to exert so much influence on me that I don't want to get a ticket. I'm not going to have the option of doing it, staying at 55 because it's the right thing to do. So if God is too evident, it's going to really inhibit our choice for God. So there's going to have to be a balance between how evident God could be. Certainly God could probably make God's self more evident to us, so there's a certain amount of hiddenness. But I actually do think, I think the fine-tuning, maybe not for life, but I've been working on the fine-tuning for discovery. I think that is the one reason it's there, that there's fine-tuning for that we can have technology and do scientific discovery, which is a whole new level of fine-tuning. So I would say some of it's there for that as one of the reasons. I think you can't say it's the reason because I think God's really, really smart, and God will have, just like I often have many reasons for why I do something, God would have a manifold set of reasons. So I could say it's one of the reasons, I think.
So, Dr. Velasco, one of the things you talked about is kind of the observer effect, that if we weren't here, we wouldn't observe that we weren't here. But it seems like there are always counterexamples, like the famous firing squad example. Like if I'm lined up to be shot at by the firing squad and they blindfold me and I hear the guns go off and I say, oh, I'm not here, I am surprised, even though I wouldn't be here if they had actually hit me. So are you thinking of the observer effect or also just the multiverse selection effect? What are you going for there?
Well, so there's just a generic thing that we have to watch out for in all sorts of contexts, which are observation selection effects. So they're real. They happen. Then there's a question in a particular case of whether what we're seeing is just the result of a selection effect or whether there's something else going on. So I think a good way to see this is to think about the case of the rare earth. And there's various ways you could tell the story where it makes it seem more or less coincidental and surprising. So for example, if we started to investigate the universe and it turns out it wasn't very big, and there was like 10 stars, and only 3 of them had planets, and we're the only planet that's even within the Goldilocks zone at all, and we have life. Okay, then you might start to think, maybe there is something special about Earth. But when there's 100 billion just in our galaxy, right? So the thing about the firing squad example is a really good example. It shows that you can't automatically say this thing which it seems like a theorem of the probability calculus. I mean, I tell my students, this is how to reason, and it turns out it's not exactly right. I say, if something counts as evidence in favor of a theory, then it has to be that you could observe the other thing, which would count against it, right? So if observing that you're alive counts in favor of God, then it seems like you would have to be able to observe something that would be not in favor of God. But the firing squad seems like a counterexample to that, which is sort of puzzling. But I think that it doesn't undermine the general principle that there are lots of selection effects. And for example, I think in the Earth case, in the real case where there's lots of planets, it's just a clear selection effect. And I think there's no reason anyone should be puzzled about why the Earth seems so special to us. It's bound to, right? And I'm not puzzled about that one. So I hope that maybe, Robin, would you agree with that? That you think that is the right explanation of the Earth
for
case?
the Earth, yeah. I disagree with your probabilistic principle. I mean, if some aliens showed up, we'd have definite evidence for aliens, but just because we can't find any evidence for, like in the SETI project, for alien signals, they could be anywhere in the universe or beyond the visible universe, it'd be no evidence against. So we can't find really evidence like that against the existence of aliens, but we certainly could find evidence for. So sometimes you can find evidence for something and it not be possible to find evidence against.
I'm going to ask one more question and at the same time invite you to ask your own questions. So we have one mic up here. Please form an orderly line. Before we do this, I'm going to tell you, simple, to the point questions, no semicolons, no comments, nothing that resembles a comment on YouTube, nothing, right? Questions, that's the goal. And we want, it's currently 8:17. My goal is to shut things down by about 8:40. I need to tell you that so that you're not like, how long are we going to be here? 8:40 is my goal. We'll try to knock things out. So while people are coming up, let me ask one more question. There's a few physics questions on Twitter saying, how do you know what would happen to the universe if you mess with the constants? How do we model that? How do we know that?
Well, because you have equations, like if you increase g, I wish I had put that down on one of the slides, but it's Newton's law, F equals g m1 m2 over r squared. You know, like if I were able to increase the gravitational constant, we'd all feel heavier. And that's just really obvious. You just plug it through, you get F, just like you know if you increase your mass, by Newton's law, you know if you increase your mass, eat a lot, the bathroom scale is going to read more. Same way, just plug it through the law. More F equals g, m1, your mass, times the mass of the Earth divided by the distance squared. You increase m1, you weigh more. F is greater. Same thing. Increase g, it's greater. So yeah, you can often figure out what's going to happen.
So my question is, for each of you, how old do you think life on Earth is, and how do you think this life was created?
Okay, I think that it's just what scientists say it is, because I think there's overwhelming evidence that it's really old. The only way I can see a young Earth position could be correct if I think this is where you have to go. You'd have to say God antiqued the world. Now, if you want to say that, God made it look old, then you could, that's a possible position to hold, but there's so much scientific evidence. God really would have to have made it look really old. Either it's really old or God made it look really old.
So between 3.5 and 4 billion years.
Howdy. My question is for Dr. Velasco. I wanted to ask if you could expound a little bit on your explanation for why God is not a good explanation for fine-tuning.
Well, I think, so if you were trying to be serious about the argument, as Dr. Collins has in other cases, you would say something like, okay, here's the probability that with no God, under secular processes, you would get the cosmological constant in exactly this range, for example. And I think it's hard to assign that probability, but okay. But now on the other side, what do you have to do? Well, you have to say, okay, so there's a God. So what's the probability that the cosmological constant would be, very close to 0 and just above it, say 1 over 10 to the 120th? I think we have no idea how to assign that probability, precisely because theism doesn't make predictions about those kinds of things. Now you can sort of say things like, well, God would probably want there to be life because life is good and he values life. But God can do that in lots of different ways. He doesn't need the cosmological constant to be low. He doesn't need a cosmological constant at all. There could be unembodied creatures. In fact, the cosmological constant could be 0. It would be just fine for life. So I think that it's not a scientific hypothesis in the way that it doesn't make predictions about what the world would be like if it were true. And by doesn't make predictions, I mean that are precise enough that we can go check, right? That's what I meant.
Thank you.
I have a question about the multiverse solution. Does the solution propose an actual, this is a question for both of you, does it propose an actual infinite number of multiverses or just a really, really big finite number? And if it's infinite, I mean, are there problems with both of those solutions?
It's usually a very large finite number, but some would allow an infinite number, but if it's been going on forever, but usually it started some point in the past, if it's an inflationary scenario.
I mean, so it depends on the version. If inflation is continually spawning off stuff, then it's called eternal inflation in the sense that it's potentially infinite, but it hasn't actually been going on for an infinite amount of time. So it's finite in that sense. But and the string theory version, for example, where all different compactifications would eventually be discovered, that's also finite, although ridiculously large. But there are some infinities around. So some people will say, well, the universe might be infinite in, say, spatial extent. That kind of infinity might help explain, for example, anything that could happen by chance will happen somewhere. In fact, an infinite number of times. But that doesn't explain, for example, variations in laws or constants or things like that. So you really have to be careful in what kind of multiverse you mean. Mm-hmm. But the ones that are especially relevant for tonight, like eternal inflation, those things are typically finite. Finite but really large.
Thank you.
My question is for Dr. Velasco. So if essentially everything came from, in some way, some element of random chance, then considering people would be from random chance, can the observations we make still be trusted? Because can random chance lead to credible observation, essentially?
Yeah, good question, and I would say yes, of course it can. So you have to understand random chance in a particular way, though. So it's very, very, very unlikely that random chance would just directly, for example, make a brain that can make reliable observations. Mm-hmm. On the other hand, if you have some sort of cumulative selection effect, as we think we do, like that's what natural selection is about. So what natural selection can do is improve the ways in which we observe the world. So if you take something like your eyes, primitive eyes are not all that great, and then they can get better, and then they can get better, and they can get better, and then 3 billion years later we have our eyes, which are quite good. And so all of our perceptions together, I think, are pretty reliable. Now, we make mistakes a lot. For example, if you think about the history of science, obviously we've made a lot of mistakes, but that's another example of science itself as a kind of a cumulative error-correcting process where you shouldn't be certain. We shouldn't trust even the law of gravity, may not be exactly right, but we have a lot of reasons to think it is because we're very reliable in this kind of repeated testing, error-correcting way.
Can I chip in just for a second there? So I think the evolution can account for what I would call practical reasoning, like getting around, attracting a mate, particularly reproducing. That's what it's all about in evolution. But like these questions we're talking about for the existence of God, those are philosophical questions, and there's no reason to think our philosophical abilities would be able to, you wouldn't expect them to be reliable at all under evolution. Our abilities to do science, a lot of science goes far, far beyond our practical reasoning. That's why quantum mechanics and general relativity are so difficult to understand. Very advanced mathematics. And they can't just simply be accounted for as, they don't seem to be a common core reasoning ability that's just applied to a new domain. There seems to be, like Howard Gardner has it, 10 different kinds of intelligence. There seems to be, I know somebody whose verbal intelligence is 3 in 10,000, but who's deficient in quantitative intelligence. So they can vary a lot. It's not just a common thing. So what gave rise to those special faculties that we can do philosophy or advanced mathematics? I think that's really a puzzle.
Thank you.
Howdy. My question is for Dr. Collins. So the reason we discuss about God is because essentially if God exists, we will act accordingly. But the fine-tuning theorem essentially, so far as I see, only prove toward it could be an ambiguous God.
Oh, what kind of God?
it could be ambiguous. God doesn't necessarily have to be a good, benevolent God, as religion suggested. So even fine-tuning theorem work out and believe there is a metaphysical force doesn't really help pointing towards that we should change our action accordingly.
Well, I think actually it does need something like an all-good God, and I'll tell you why. First of all, and this is what Dr. Velasco pointed out, you have to give, and you think this world's really improbable just by chance, but in order to get a good argument going, you have to be able to perceive a reason why God would create it. If there was no reason, just like you do in the case of Abraham Lincoln, you could perceive why somebody would create that pattern. So that's what makes it special. So you need to perceive that reason, so you need something non-arbitrary about God to give you the reason. If it's just an arbitrary reason, then it becomes a coincidence God had that reason. So the moral goodness is it gives you a non-arbitrary reason. This is something the philosopher Richard Swinburne has stressed. If there's a good, there's been a common thesis in philosophy that perceiving what is good, unless you would automatically be motivated to do it. So the reason people don't do good is either they are ignorant of what is good or they have contrary desires. But God is not constrained by anything, so then you would be able to think that God would be perfectly good. And so you get a non-arbitrary explanation for why God would create a world like this. Now, what about God being partially good? We're a being that's partially good and very powerful. If you're partially good, you'll want to be better. And if you're very powerful, you'll make yourself better. So either God's going to go all the way to the extreme of being perfectly good or be morally indifferent, in which case you wouldn't have any expectation for a world like ours, or perfectly evil.
If I can say something. So I agree that you don't want it to be just kind of an arbitrary thing, like what reason could any being possibly have? But I don't think it's crazy at all to think that the universe could be designed by some not perfect being. If you think about, say, our future, it seems to me perfectly reasonable that humans or their descendants might design various kinds of experiments and run various kinds of simulations, and if we had the power to, we could create a universe. And it doesn't mean that we're perfect. We do need some reason, but for example, they could be doing it to experiment on us or to learn about us. Or, I mean, there's all sorts of reasons you might want to create the universe. You don't have to be perfectly good.
Yeah, but the reasons we have might come from, could be explained by evolution, and so you have to give an account of why we have those reasons. So you would say it was our evolution bred in us interest, need to survive, but then that explanation is just going to kick the problem back, because now you're going to have to ask, where did that context come from? Where did we come from? Whenever you hypothesize a finite being and various laws, you just push the problem back. And so if you want an ultimate explanation, you can't appeal to that. You have to have a non-arbitrary reason. It has to somehow come from the very nature of things, why God would create the universe. If you just appeal to aliens and what brought the aliens about, you just knock the question back. Does that make sense?
Howdy. I was just wondering if there's I was wondering with the multiverse idea, is it possible to have subsets of universes within a overbearing size universe? And if so, how would both of your guys' sides deal with that idea?
I think you just get back, you'd just be a variation of the multiverse. So if you bought into the Everett idea, and you both bought into that in inflation, you would have, within each inflationary cosmos, you would have all these quantum splittings occurring, and so you'd have a whole set of universes within a single larger structure, and then you'd have multiple larger structures, so certainly you could have that.
Okay. Yeah, you can. In fact, I think that's probably the normal picture. So, when a universe splits off, I mean, the original one is, in a sense, still there. So there's a sense in which it's nested, right? So I, the machine, create universe one, and then within universe one, inflation occurs and there's another universe. So it's nested inside there. Now, one thing you asked was, okay, so how does this change the picture at all? I don't really see why it would change the picture. What matters, so for example, for the selection effect, what matters is if, as long as somewhere in the extent of the megaverse, or whatever you want to call it, there is going to be the conditions for life, then the fact that we are in a place with conditions for life is explained. So it doesn't really matter if the universes are nested inside each other, or if they're like spatially separated, or if they're like parallel universes that aren't even connected in any causal way. What matters is that there are some with conditions for life that you would expect to see. Right?
Yeah, I would agree with that.
My question is for Dr. Collins. I was wondering your opinion on Christians believing in the Big Bang as opposed to creationists believing in life as it's stated in Genesis, and just kind of where the Bible fits into the Big Bang.
Okay, first of all, as stated in Genesis, you mean a literal interpretation of Genesis?
Yeah,
But
because some people believe that.
Yeah, and Genesis has a multiple set of interpretations you can give. So I think science helps sort through which is the reasonable interpretation, whether it's a literary interpretation, a day-age theory, or et cetera. So that's first part of your question. Second, I think the Big Bang theory historically was a theistic theory, not it was first promoted by a Belgian priest, and then for a long time atheists resisted it because it suggested that the universe had a beginning, which seemed to suggest a creator. And in fact, the philosopher William Lane Craig has tried to develop that argument, what's called Kalam cosmological arguments. The universe has a beginning, there must be a creator. So it wasn't until the 1960s with the really strong evidence from the cosmic microwave background radiation and also other evidence of the abundance of elements that it really became decisive evidence for the Big Bang, and the scientists switched over to believing in the Big Bang theory. So I actually think the Big Bang theory historically was a support for theism, and second, that it's perfectly compatible with Genesis.
Thank you.
And if I can say, I know you didn't ask me, and I know you were asking about biblical interpretation, but
Sorry.
it's fine. I'll say that it's worth reminding people in the audience if you didn't catch it from our talk. So things like inflation, the multiverse, lots of other scientific theories, those things are speculation. You know, most cosmologists accept some version of inflation, but it's definitely not a guarantee. There's serious cosmologists who deny it. The Big Bang theory is not really like that. So the Big Bang is so well confirmed, or at least some weak version of it, that there was, some sort of hot, dense state of matter 13.7 billion years ago. That is scientifically so well confirmed that to deny that on the basis of your interpretation of the Bible or something is really a much harder leap to make than something like, if somebody comes along and says, I think the universe is infinitely old or infinitely in space, we don't really know that. Mm-hmm. But frankly, we do really know about the Big Bang.
Well, because you could say God made it look. Big Bang theory has a prediction about that the universe is permeated by cosmic microwave background radiation, and it has a certain, what they call temperature, and around a certain wavelength. And it also has these ripples in it. That's just a prediction. That's what they find. So God would have to make it, why would God make it look like that prediction was true if it wasn't true? God would be like deceiving us unless God wanted to. Then you can't even appeal to an antiquing of the universe. God made it look like this theory predicts all these detailed things, and then God makes it look like the predictions are all true. That doesn't make much sense.
Yeah. Thank you all both.
Howdy, thank you guys for being here. So this is primarily a theological question, and so it's addressed to Dr. Collins, but I'd be interested to hear Dr. Velasco's perspective on this as well. What sort of theological presuppositions or attributes of God, and basically what kind of God do you need to have in order for the fine-tuning argument to be compelling or feasible, and does the Christian Bible provide a description of such a God?
Okay, I think you have to have a kind of something like a classical theist God, a God that omniscient, omnipotent, because I think just a real short answer, if you start having a finite God, then you have to have some set of laws, et cetera, determining what God's limits are. That, for example, God can create unicorns but not centaurs. Well, then what set of laws are going to determine that? So then you have to reintroduce a bunch of fine-tuning of new laws that determine the limits of that being. So you're going to have to have being unlimited. And I said, you're going to have the attribute non-arbitrary, because you can see this in ordinary cases. Like if I have an ink spill, I could always invent some purpose of my roommate just wanted to produce an ink spill just of that structure, so it's designed, but it's not going to be a good explanation because that's an arbitrary desire. There's no reason why the roommate would have the desire to produce that exact ink spill versus all the others, where I could give a non-arbitrary reason for the picture of Abraham Lincoln. So then goodness, like a classical, if you take moral objectivity, and a very common thesis like Plato had and others had, that goodness has its own attraction. So a perfectly free being who knew what was good and was able to bring it about would bring it about. And so a being that did not, you just think they just weren't aware of what's good. If you're aware that something's good and you have no contrary desire, you would do it. If you didn't do it, I'd think, well, you just didn't recognize it as good. So it gives a non-arbitrary desire, so then you get perfect goodness from that. It needs to be perfect. Just with omnipotence, you're going to get perfection, because if God were just partially good, God would then improve God's self and make God's self perfectly good. So that would be a stable point. So I think you actually do get a long ways towards the classical theistic tradition. Now, the conception of the Bible, people think that that's implicit in the Bible, the classical omniscient, omnipotent, but there's not explicitly stated anywhere.
Okay.
So is that?
Yeah, absolutely.
Well, I mean, it seems absurd for me to disagree with the theological implications of the fine-tuning argument with Robin Collins, but I'll do it anyway. So I think that insofar as the fine-tuning argument is a good argument, what it's really a good argument for is just that there's some sort of design or purpose behind the universe. And I don't really see that you need anything like classical theism to get that. I mean, as I mentioned before, I think you can get it out of aliens or some sort of powerful designer. You can get it out of maybe we're in some kind of simulation. In the end, I don't think those arguments actually work for reasons that Dr. Collins mentioned, but actually I don't think the fine-tuning argument for God works either. So I think there's a sense in which I feel like the argument is just as powerful. On its face, it looks, the universe is crying out. It's, look, I'm here for a reason. There's some purpose behind it. But I don't think that automatically gets you to this kind of classical theism, certainly not, morally good or, certainly, all-knowing or anything like that. It would have to be pretty powerful, but no reason to be perfect, for example.
I would just repeat what I said. I think if you use aliens like we're a simulation, then you just get the fine-tuning of where do those aliens come from, what fine-tuned their brains, and you haven't made any explanatory progress. So if you're going to make explanatory progress, you've got to get to a being that doesn't need to be fine-tuned. And I think you need a being, like in the case of God doesn't have parts, so there's nothing to fine-tune. And the desires of God can't be arbitrary, because then you have to fine-tune the right desires. So you're already assuming a background of desires. God would have desires like we have, but the reason we have a lot of our desires is because we're embodied conscious agents who evolved. And so we need to have, God doesn't have desires to have sex because God didn't need to have sex, right? So we have all these desires we have that you just couldn't project on God.
So I think here's what we're going to do. If you're in the Q&A line, stay where you are. Please, nobody new join the Q&A line, and we'll aim for about 10 more minutes and shut it down at 8:50. All right, lightning round, go.
Okay, so Dr. Velasco, I think this question falls more in your realm. Okay, too close? Okay, how's this? Okay, is this good? Okay. I was looking at your additional slides, and it said objection for the creation of God. Now, when we take, I suppose this would fall more in the theological and Christian realm, but if God is this perfect being in the Christian realm and just a being in the theological realm, which is the reason for all finely tuned universal constants and all entropy and everything that happens, but he's something that we're literally created in his presence where we are not supposed to physically understand what he is. What's your position on there being a creator of this creator that we're not supposed to understand? And what he know about goodness and evil and all the stuff that we're debating right now?
Well, this is, I mean, first of all, that was Dr. Collins' extra slides. But I take it that, so the objection is, it's sort of like the who created God objection, or where did God come from? I think that's a powerful objection, but Dr. Collins doesn't, so maybe he should address how to answer this objection.
Please do.
Because I'm real surprised no one's asked this question so far. Every time I speak at a non-Christian college, always the Skeptics Club comes out, and they read their Dawkins, and this is the first question they ask me, and they think they're going to nail me on it. That's just exactly what happens, and it hasn't happened here. Maybe that shows you something about your university. Okay. Okay. Okay, so this is an extra, oh, it's not up there?
No, yeah, it's not up there. It's okay.
Okay, so it's an extraordinarily common objection people give, like, if the universe needs a designer, shouldn't God even be more wonderful and even be more in need of a designer? So the argument presupposes that God would need to be fine-tuned. And if God was an anthropomorphic God, like, you know, being like us that was doing a simulation, then that would be a legitimate objection. Then God would have a brain in maybe a higher dimension that would itself need fine-tuning. But classical theists have never thought of God that way. God doesn't have parts. What you get the whole fine-tuning problem is there's some kind of components, like in the picture of Abraham Lincoln, the ink spots, light and dark ink spots, and they have to be arranged in just the right way to fine-tuned in order to have a picture of Abraham Lincoln. The constants and the laws have to be adjusted in just the right way. They could be thought of as sort of like components. But God doesn't have any components like that. And so there'd be nothing to fine-tune, so God solves. There is no who designed God objection. It's just based on a completely false perception of what classical theists claim. The real issue there is which is more plausible, to believe there is a being like that doesn't have parts, that can think, and that is infinite, etc., or that either a multiverse is true or that it just all happened as a brute fact. And I think the former is far more plausible.
Lightning round, go.
All right, this question is for Dr. Velasco. So, all right, obviously we have space, time, and matter, and you can't have two of them without the third. So you obviously have to have someone outside of that realm to create those all consecutively at the same time, or like someone or something. So how did they all come about then?
Well, I'm not sure why you...
Cosmological argument.
Yeah, I'm not sure what you mean by that, if you can have like two but not the third or something like that. But if you just ask where any of them come from, I mean, it's just as puzzling. And, you know, the answer is I don't know. We know where our space-time came from. That's the Big Bang. Now, if you say something like, well, what was there before, or what was going on, you know, we don't know. We have some guesses. So, for example, the multiverse story is supposed to be one of these kinds of examples. It's not yet well confirmed. And, you know, it's a puzzle. It's true. It's a puzzle. And I think that it's, unlike Robin, I think it's just as puzzling if you have a God. It doesn't really solve the puzzle. But, I mean, the answer to your question is I don't know where everything comes from. But I also think that you don't know either, or that anybody knows. So.
Well, I think God solves the puzzle because God, if it's just the puzzle of where fine-tuning comes from, the multiverse needs fine-tuning to work. God doesn't have components, so God doesn't need any fine-tuning, so at least eliminates the fine-tuning problem. It solves that bit of the puzzle. You might think there's other objections to God, but at least that bit's solved.
Hey, y'all. Okay, so my question is for Dr. Velasco. So what is your evidence for God not existing? You yourself said that you should have evidence. What is yours? And don't you think it's a little ironic that you believe in the Big Bang Theory when a Catholic priest is the one who founded it and believe in both science and religion?
Well, I don't think I said anything tonight, but I'll reveal myself. In fact, I do not believe in God. So now, why don't I believe in God? Well,
what's your evidence?
What's my evidence for that? So I'll stick to a particular version of God, say the classical theist God.
I think they're actually, frankly, it's kind of incoherent. I don't think that there could be a being with desires and preferences and thoughts and no body, for example. I think matter, for example, mind comes from matter. I think the problem of evil is pretty devastating. I think if there were a morally perfect God, he definitely wouldn't create a world like ours. Lots of bad things have happened, and if God could intervene, he would have. So the fact that he didn't tells me that he couldn't intervene or that there isn't such a being. So that's my evidence. I think that there's a lot of different things going on, and it would take years of discussion about the history of religion and sociology, and tonight's maybe not the appropriate place for that. But those are my two fast objections.
So isn't it?
No, let's keep going. Let's keep going.
So there's like a whole lot that we don't know the answers to, but one thing we certainly have to die one day. What do you guys, or what's y'all's take on like what our lives comes down to?
What was the question?
Like, what do you do with death? What's life's meaning?
Yeah, I think there's life after death, but I think that would only be plausible under theism. So things would have to be well designed for that to happen. So I do think there's life after death. And if you're a theist, you're going to think that appealing to the problem of evil is there needs to be some much larger good to have an all-good God creating a world like this. And if we just died, a lot of people just suffer, and that's it. That would be a very unjust God. So I do think there has to be an afterlife as actually an essential component of theism in the face of the evil in the world.
I think life is a physical process. I think that things like beliefs and desires and consciousness arise out of physical processes. And when you die, that process stops, and so you don't have a consciousness anymore. So that's it.
Howdy. This is for Dr. Collins. So this is on what you were saying about the fine-tuning. You said the probability of us being created the way we were was 1/10 raised to the 10 to the raised to the 120th power?
That's the low entropy of the universe, and that means effectively that there's other galaxies we can see and stars and things like that.
Right. So I was just curious, considering we have no evidence, obviously, of other universes, nothing to compare it to, and considering that's such an insanely, unimaginably large number, where did that number exactly come from?
Well, it comes out of statistical mechanics. Usually what's done in statistical mechanics, which is one of the pillars of physics, is you give an equal probability distribution to all the possible material configurations, both configurations in space and in the space of momenta. And that's where that number came from, is that's the number of possible configurations. We're in a very special configuration. It's a very small proportion of that. So that's how you would get that calculation. Statistical mechanics is the reason why, when you blow up a building, when dynamite and it falls, and you can't get it back together just by another piece of dynamite because things go from more ordered states to disorder, and it's all a matter of probability. So it's a highly successful theory, and it uses this equal probability distribution.
A quick question for Dr. Velasco about the rare earth idea. With respect to the size and variety of the universe, where would you draw the line of the Earth being special and the Earth being not as special?
Where would I draw the line? I don't think this is a particular threshold problem. I think that the more planets that there are, the less the special Earth is in need of explanation. I don't think it's like, well, there needs to be at least 100 billion. So there's no precise number. But I do think if there were 10 planets in the entire universe, then actually probably the Earth would need some explanation. But given the number that there are, it clearly doesn't. So somewhere in between there is the answer.
Appreciate it.
So I think we've just about hit our limit, so I know there's still a few questioners up here. What we're going to do is we'll still hang out even afterwards, and if you have additional questions, I'm sure there's more. Why don't we go ahead and come on up. Zach, why don't you close us out? Thanks, sir.
Let's thank our panelists tonight. Again, we'd like to thank you all for coming out tonight and to all the events this week. Just as a reminder, there is an encore next week, next Thursday specifically. Just as a reminder, also for your response cards, please fill out the back of those cards and turn them into the ushers as you leave. And then lastly, just as a plug, if this conversation has been even remotely interesting to you, Ratio Christi talks about this kind of stuff literally every single week, every Thursday at 8:30. So if you're interested in being involved as a student, please come talk to me or Dr. Green if you're involved or if you want to get involved as faculty, and we'll hook you up. Again, thank you so much, and y'all are dismissed.